Newton's law of gravitation, video 1. You can see you'll need a pen and a paper, so feel free to pause the video to get that before progressing any further. Our success criteria today, so these are the things that you should be able to answer by the end of the video, and you'll have to ask yourself whether you do or not as well by the end of the video. Can you state Newton's law of gravitation? You should be able to state that. You should be able to give the formula and calculate values using Newton's law of gravitation formula. Number 3, you should be able to give the relationship between the force of attraction between the objects and the distance between those objects. And you should also be able to give the relationship between the force and the mass of the objects attracting each other. And 4, you should be able to explain how Newton's law of gravitation applies on a planetary scale and our human everyday, day-to-day scale. So, before we get into it, can you answer this question, A or B, and also give a reason why? So, if you're skydiving, you fall out of a plane, which of the following is true? So the first option is, when you fall, you accelerate towards the Earth then stays at rest, and eventually you hit the Earth. Or B is, you fall, you accelerate towards the Earth also accelerates towards you, and it stops basically when you hit the Earth. So basically, A is you're moving, the Earth is at rest, B is both of you are moving towards each other. Answer A or B, give a reason why. And also question 2. If you fall out of a plane, is your acceleration constant at 9.8 meters per second squared, or does that acceleration vary as you get closer to the Earth? Okay, if you needed to pause the video, you could have done that. So let's get to Newton's law of gravitation. Now, Newton's law of gravitation, the purpose behind it is to explain physical actions in your environment. That's why we come up with any kind of concepts in physics. So we try to come up with an idea to explain what happens, and then we put some maths on it, essentially. That's what physics is all about. So when Newton observed specific phenomena, the model that he put on it stated, 1, he believed that objects with masses attract each other, they don't repel. He stated 2, the attraction depends on the distance between the masses and also the size of the masses. So what he's saying there is, if the objects have a greater mass, then the force of attraction varies. And also if they're a further distance away, the force of attraction between them varies. And then the third one, both objects will experience the same force of attraction. So this was his model, and he built Newton's law of gravitation on it. Now, the formula for it is very straightforward, and we'll see how the masses and the distances are related to the force of attraction. So what he said was, if you have 2 masses, m1 and m2, that are a distance r apart, then both of those masses experience the same size of force, but in opposite directions. In other words, the 2 masses are going to attract each other, they won't repel, and the size of the force F1 and F2 will be equal. He also said that you could calculate a value for that force by multiplying the size of the masses together. So if you multiplied m1 by m2, that's mass 1 by m2, and then divided by the distance squared between the two of them, that would be proportional to the force. And then if you multiply that by a constant, which is big G there, which is called the gravitational constant, you'd be able to calculate the magnitude of the force. So Newton said the force of attraction between any 2-point masses is directly proportional to the product of the masses and inversely proportional to the distance squared between the two of them. Okay, let's have a look at that in action. Now, you can use this app if you want. I googled PhET gravitation, and what we have is mass 1 and mass 2. We also have these guys are experiencing force of attraction, and that's equal and opposite. So let's decrease the distance. If I decrease the distance, we can see that the force of attraction increases. And likewise, if I increase the distance, the force of attraction decreases. Okay, so that explains the relationship with F and R underneath the line. So there's an inverse relationship between the two of them. All right, now let's see what happens when we half the distance. So I'm going to put in a value here. Look, we can see that the forces are equal and opposite, and the distance between them is 4 centimeters. Now if I half the distance, and the relationship is 1 over r squared, halving the distance should multiply the force of attraction by 2 squared, so by 4. So that's going to go up to a much larger value. So we want to drop it to 4. And we can see that that value is 4 times larger than the previous one. So the first thing we notice, based on the PhET application, is the force of attraction between the 2-point masses is inversely proportional to the distance squared, meaning that if I double the distance, the force decreases by 4. If I triple that, the force decreases by 9. If I multiply the distance by 5, the force decreases by 25. Okay, let's put these back to where they were. And now let's vary the masses. So what Newton's law says is if I increase the mass of 1, the force of attraction should increase as well. We can see that happening. And it doesn't matter what the masses are of each of those. The force of attraction is the same on both of those values. So Newton's law states that the force of attraction is proportional to the product of the masses, so increasing either of those increases the force of attraction, and inversely proportional to the distance squared, so if I increase r, that will decrease f. This g value is just a constant, and we'll see that when we deal with calculations. So, pause the video and answer these. What's the relationship between the masses and the force of attraction? What's the relationship between the distance and the force of attraction? Both of those for Newton's law of gravitation. What is the g value? And then also, 2 final questions that I'm interested in. Why do you think we don't feel a force of attraction towards everyone? Or do we feel a force of attraction towards people? And then, if that's the case, why don't we experience it? Okay, and the last question is, if we have a force of attraction according to Newton's law of gravitation, what does that force do to the objects? And that's more of a general question. What do forces cause? Okay, so you should have a few answers down on the page right now. Let's go to using the formula. So, what is the force of attraction between 2 75 kilogram people that are standing 50 centimeters apart? So the first thing we always do here is write down the variables. My masses are 75 kg, so m1 is 75, m2 is 75. The distance is 0.5, so my r in meters is 0.5. Now you should remember that your marks on the leaving cert are going for writing down a formula, making a substitution, and getting an answer. The g value, the gravitational constant value, I haven't put down here at all. That's in the log tables, and I'll show you where that is via Edmodo. So that's where your marks go for. Formula, making a substitution, and then your answer is roughly 1.5 by 10 to the minus 6 newtons. Now that is tiny. So that means 2, I suppose, regular size people, like 75 kgs, is approximately my mass. So roughly I experience a force of attraction of 1.5 by 10 to the minus 6 newtons. Tiny. So I do experience it, it's just really small that it's not noticeable to me. Now let's have a look at another part of the question. What acceleration will each person experience, and what will the direction of the acceleration be? So we know there's a formula. We have the force and we have a mass, and we know the formula is F is equal to ma to calculate the acceleration and how it relates to the force. So when you sub it in there, the acceleration is 2 by 10 to the minus 8 meters per second squared, which again is tiny. So if those people could move towards each other, the acceleration would be really, really, really small, and you may not even notice it. That acceleration is always in the same direction as the force, so it'll be directed towards the other person. Okay, this is the end of the first video. So I'll give questions on Edmodo. I'd like you to do these now.